questions that we want to see, do go over, have questions about? I see a bunch of 1s and I saw some 4s, so we'll do those two. So with number 1, translating is something you cannot do on Desmos. That's something you have to know. So if we are translating the following, the quotient of, so everything after those words, we're going to be dividing. Oh, right, 30, not that. Okay. Well, this one can be done. This. My bad. I forgot what. If I were to make a table for this and put in all the numbers. I can see that these do make a line, they do go through the origin, and if I counted the slope or the constant k, I just zoomed a bunch. I'm going up. Up 1 to the left 5. If I kept doing that, I'd run into this one. If I kept going down 1 to the right 5, it would run into this one. So this one is direct. And then because we know it's direct, it says state the correct variation equation. So if it's direct, we need our k value, which I found was -1/5. We also could have divided 3 by -15, 1 by -5, -2 by 10 to figure that out as well. And then your equation would be y equals -1/5 x, or y equals -x over y, either or. Questions on that one? Great. Number 4, I'm also going to do that one in Desmos. So if I plotted the point 4, -1, and I need the equation. I'm going to type in my y equals mx plus b. Add in all my sliders, change my m value to -3/2. And then I'm going to move my b by either hitting play or moving the slider until it goes through that point. So at 5. So then my equation would be y equals -3/2x plus 5. So if you did the work, that's great. If you just did what I did, make sure you use Desmos for both of them, really. Make sure your name is on your answer sheet and go ahead and pass those up. I'm going to show you up here, if you like this method and want to use the algebra tiles, I don't have them in the class right now, but I can go get some while you're practicing, if you want some later. Right, so this is a monomial multiplied to a binomial, but we'll get to the binomials in a second. If I had something like this and I was showing it using algebra tiles, I would need to show how I would write out or draw out -4, which would be the -4 ones, and then the x minus 2, which would be 1x and then minus 2. And then you're multiplying each piece together. So if I multiplied x times -1, that would give us what? See? -x. And you guys can just shout these out. And then that's going to be the same for all of these. And when you're doing this with algebra tiles, you want to kind of make this into a rectangle. On the website, you don't have to actually do this because it'll form together. This website is a side link on Canvas if you do want to play around with this later. And then -1 times -1, positive 1. So that would be the same for all of these. And then it's going to show me what that rectangle or square would be, and I could count up whatever's here, -4x plus 8. If I had any positives and negatives of the same thing, the 0 pairs, I could cancel them out and then count what's left. We'll do one more of these and then go on to binomials. So we just found -1 times x is -x. I think it's still 1 times 3. And -1 times -1 is positive 3. Or positive 1, sorry. Now when we have binomials times binomials, we do the same thing. So x times x would be what? Not just x.
2x.
Not 2x.
1.
Not 1x.
X.
X squared. We're multiplying the like bases, so we're adding the exponents. And then x times 1 is x. And then 1 times 1 would just be 1. So then if we were to read off that total, what do we have? What do you see there? X squared plus 4x plus 1. Okay, let's do one more of these and then I'll show you how to do it algebraically. Wow. Okay, so x times x would give us
X.
X squared. That's going to be the same 3 times. And then x times 1 we know is just x. And then 1 times 1 is just 1. So then, what would that total be? Counted up how many x squares, how many x's, how many 1s, what would that be? It's 3x squared plus 5x plus 2. Before we continue this algebra, I meant to do this at the beginning. Everyone look over here. What does this say? Algebra 1, SOL, May 15th. That is your SOL date, so keep that in mind. We will have more SOL practice as we get closer and closer to that date. Alright, so if you like that method and want algebra tiles after we finish this, I will go get you some. If you like the algebraic methods, stick with that. So I'm going to show you a few different ways that we can do this algebraically. Because we have two sets of parentheses, we're still going to distribute, but you have to think about this like you're double distributing. So one way we can think about that is take the first term, multiply to everything in the second. So that would be like x times x plus 7. Now once you get the hang of this, you won't have to write it out like this, but if it helps you, you can still do that. And then take the second term and multiply it to everything in the second set of parentheses. And then we're just going to distribute everything. So x times x would give us x squared. X times 7, 7x. 5 times x,
5x.
and 5 times 7.
35.
There we go. And then we would combine any like terms that we have. So if we did that, what would our final answer be? X squared plus 12x plus 35. And that would be our answer. While you're practicing on decimals, if you put this in and the original in, they should overlap. Same thing in your calculator, you can do that as well. Questions on how that works? Okay, so now I'm going to show you a more specified way of double distributing using the mnemonic FOIL.
Wait, do I need this?
Okay, so FOIL is first, or stands for first, so that's the first terms in both. Outer, so that's the outside terms in both. The inside terms, or the inner, so that's your inside terms in both sets of parentheses. And then last, which are the last numbers in both sets of parentheses. So we're going to do this using the mnemonic, writing out each piece, but once you get the hang of this, you won't need to do all of that. So if we multiply the first together, x times x would give us x squared. The outer terms, x times negative 6. X. The inside terms, 9 times x. Would give us 9x. And then the last terms, 9 times negative 6. Negative 54. So then you would combine them just as we did before. If we were to combine all the like terms, what would our final answer be? X squared plus 3x minus 54. Questions on that? We're going to do that once more, but without separating it like this. If this helps you see it visually, what you're doing to everything, keep doing that. But if you can do this next part without doing that, that's also fine. So I'm going to multiply the same things first. So 5x times x would be what?
5x squared.
5x squared. The outer, 5x times negative 4.
Negative
the inner 2 times x,
2x.
positive 2x, and then the last 2 times negative 4, negative 8. And then combine your like terms. What would that give us? 5x squared minus 18x minus 8. So the double distributive and the FOIL, they're really the same thing. This is just how we do it specifically, and the other one is just, it's kind of the same thing but written out a different way. So if you like either of those methods, use that. I'm going to show you one more method that would help. But if you like the other ones and don't like this one, ignore it. So this will relate to science if you've seen this, depending on what science class you are in. How many of you have heard of or seen a Punnett square? Okay. So this is going to kind of relate to that. So the square or rectangle depends on how many terms you have in each. So this is going to be a 2 by 2. Draw a 2 by 2 square. Big enough to write in, but small enough to write around as well. And then it doesn't matter which terms you put on the top or the side or which side you use. You just have to use 2 of them. So I'm going to put 3x minus 10 on the top and 2x plus 1 on the side. And then we're going to take each piece, kind of like the algebra tiles, and multiply them together. So 2x times 3x would give us
5x squared.
It is x squared, not 5. You're multiplying.
6.
6. There we go. And then 2x times negative 10.
Negative 20.
Negative 20x. 1 times 3x. 3x. And then 1 times negative 10.
Negative 10.
And then you could either take them out and rewrite them into 4 terms, then combine your like terms, or you can combine them while they're in the box. And then rewrite your final answer. So if we were to combine like terms, what would our final answer be?
X squared minus 7x.
6x squared minus 17x minus 10. So you can choose of the different methods: algebra tiles, double distributive, FOIL, specifically the box method. Use any of those. They should all work. Questions on that? I'm going to do one more example. You guys have it at the bottom of your page, where you are multiplying a binomial to a trinomial or a different polynomial, more than 2. The double distributive works here. The FOIL not really because of the middle term. The algebra tiles could work here. You would just have to draw it out or come up with or use the manipulatives. The box method also works here. So I'll let you guys choose between the double distributive and the box method. Which of those 2 methods do you want to see here?
The box method.
Okay. So with the box method, you're going to do a 2 by 3 or a 3 by 2. It doesn't matter which way. Rectangle. Where the 2 would go on the side, x plus 2. The 3 would go on the top, x squared plus 3x plus 4. And then we would multiply each thing. So x times x squared would give us 1. multiplying x times x squared, what would that become?
X squared.
Not x squared, remember you're adding the exponents. X cubed. And we're just going to go across x times 3x.
3x squared.
3x squared. X times 4. And then 2 times x squared.
2x squared.
2 times 3x.
6x.
And 2 times 4. So then in this case we have 2 sets of ordered pairs of, I don't know why I said that, of like terms. And you would combine both sets and rewrite it. So highest exponent first, x to the third. And then if we combine our like terms, what would the rest be?
Plus 6x squared.
Be careful, we're not multiplying here, just adding.
5x squared.
5x squared
Plus 10x.
plus 10x.
Plus 8.
So when you have a binomial times a trinomial, you'll have 4 terms. When you have a binomial times a binomial, you'll have 3 terms. Questions on how this works? So you guys are going to have a lot of time to practice today. One, you could keep practicing in these notes. There are a bunch of practice problems. The last few pages deal with binomial to binomial or binomial to polynomial. I'm also going to pass out your review because your quiz is Tuesday and your test is Thursday. You'd be working on that, work on this, work on the previous notes, practice. Remember, you guys have 2 Delta Maths that are due today, 2 that were due last class. Also, you have SOL A4C through 5B that is due on Tuesday. So you have plenty to be working on. Be working on